maths methods. Now, other schools will do it differently because they feel that if it's in the book, they do it. Well, no, this school just prepares you for the exam. So we just teach you what you need to know, and that's it. Okay. So adding them, subtracting them, what they're there for, what you call them, how do you describe the size of it? Don't worry about that. All right. All you need to know is that we always work with what they call a 2 by 2, which means that there are 2 rows and 2 columns. Okay. And then usually it's multiplying either by a point or by your XY. Just casually walks out.
No, he has an assumption for us.
Oh, okay. Thanks for letting me know. And I just recorded that. All right. And then it'll be plussing some translation. Now, the tables that I've given you describe everything in the different parts of the matrices here. All right. So that's what all of it's there. Basically, all you need to know is to be able to pull out the information from the matrices. So singular term is one matrix, plural term is matrices. Just you need to be able to pull out the information from it and apply those transformations to the function or the point that you're given. All right. Multiplying them, that's not so important. But if you wanted to know how to do the mapping, essentially what it is it's this one times that plus that. All right. So you have your, we'll say your new X and your new Y. So like your whatever, X dash and Y dash. It equals to, so let's just chuck in some nominal values here. We'll put an A there, put a B there, and we'll put X is a K. Is that right? Yeah. Other way around. Oh yeah, sorry. The X is always the H. And then the K on the end, right? So then what you'll do is, doesn't mean we're all here now. Ordinarily, to answer your question, there is a number 0 there and a number 0 there, which is why when you're creating the X mapping equation, the Y is zeroed off. Okay, so yes, it is the A term times the X term plus the H term. That's how you get the equation for the X dash. So it's the new X is dilation plus plus the H. Okay, and then same too with the Y as well. It's this times that plus that. Right? And so forth. And then you rearrange the whole thing, substitute it in, and then rearrange it back to make the Y dash and X dashes, or the Y dash the subject, and there you go. That's your new equation. That's the mapping method. But the reason why I've given you the table with the full matrix in there, printed out, and explanation of what each one does is it's because I want you to learn to get used to remembering how to apply each one. Okay, so in the table that I've given you, they're all here. All right. What happens here? Actually, I should really, if I've given you this with that as well, cross out this entire row in the table because you don't need that one anymore. They don't do, oh no, if you have the notes. Yeah, it's in the updated table, it's not, I've already taken it out. But in the notes, so this table that I've given you in the notes, cross out the one. The one I just crossed out, inverse swapping XY, cross that out because I won't give you that anymore. That one is a bit, not outdated, just they simplified the course a bit, so they took that out. So the textbook questions on that and the checkpoints questions on that, skip those as well. All right, so you won't have one where it's a, you won't have one where it's like this, where the new X, the new X equals the old Y plus the H. You won't get those anymore. Okay, so that's essentially an inversing, swapping them over. It's just going to be, the numbers will be there and there. And these two numbers will always be a 0. Okay, it won't be the other way around. That's all. In terms of then applying the matrix, like I said, just get used to reading off, right? remember, if you dilate from the x-axis, which number or which coordinate value is the one that actually changes? It's the y. So dilate from the x means that you're timesing the y value. So the dilation factor, the k, whatever it is, if it's 2, then that's a 2 there, goes here. Okay. Note that this is not a half, it's 2. But then when you substitute it in, oh, well, this one is the same as the number in front of the function. But for this one here, if it's 2 from the y, there's a 2 in there, but then you divide it by that 2. Okay, so just careful, don't get those confused. Reflections. So if you reflect in the x, it was the y that changed. So the y is the one that's times, okay, which is also the same thing as timesing in front. Reflection in the y, it's the x that changes, times it on the inside. Everywhere, every x in the function, just change it to a minus. All right. This one, our esteemed colleague, Mr. Worsnop, told me that I should probably flesh it out a bit more. If it's a plus a here, ends up being a minus a is what you substitute in. Okay, everywhere inside, zoomed into the x's in the function. Same with the y, except that because it's then plus back to the other side, it's just tacked onto the end of the function with the same sign. So if it's a plus b there, you just tack on the end of it, a plus b on the end of it. So if this one is the same sign, but this one is the opposite sign. And that's all. Okay, so when you're doing these, do some now. Scroll down. All right. So yes, the book does go through in detail the mapping method, which you can try and follow if you want, or I can go with you if you like. But really, I just prefer you to try and do this by identifying what it is. So this one means that reflection in the x-axis means which one do we change? We change the y. So that's why the negative is down here, right? When it's like that, if you remember what I showed you in my example, without getting too messy, all right, this number multiplies to the x, this one multiplies to the y, okay? So if you just replace this matrix here with the set of coordinates, it'll be exactly the same thing, yeah? So whatever number is here, just times it straight to that. Whatever number is there, times it straight to the y. If it's a set of coordinates, same thing again, all right? So then in this case, the number one here just times to the 2, stays as a 2. The negative times the y becomes a negative 3, which is what we expect it to be anyway, because the reflection in the x-axis means the y goes negative. So the starting point was 2, 3. The end point should be 2, negative 3. It's just doing exactly the same thing, but using the matrix notation. We've all gone quiet. All right. Dilation from the y-axis means that it's the x term that's multiplied, right? Which is why the k is up there, right? So then you don't know what the k is, so you just times it by the x that's in there. That's all. Sorry, this is boring you.
No, I'm just tired.
All right. The linear transformation. They're a bit particular about the matrix notation as well. All right. It is written like that here. So just so you know, university level to understand why it's r squared, but it just, when they show you that, that means it's referring to a matrix that's going to apply a series of transformations to a function. Okay. Yes. All right. Then, and I really should have tried to make this on the same page. Oh, there you go. So here, they say that it's r squared to r squared, right? Now, these checkpoints questions, I could probably stop recording it there. For this one here, it's easiest if you first make y the subject. So you get y equals, I just plus it over minus 3. So it's x over 2 minus 3 over 2. All right. So you are changing the x to become a negative x. So just zoom in to like that. All right. You are timesing the whole thing through by 2. So then it becomes 2 brackets negative x on 2 minus 3 on 2, which is then negative x minus 3. Then you are 81 to the x. So you zoom into the x again. I think I'm gonna, and I'm getting all of this wrong. All right, so shifting it, so it becomes negative x. And I'm recording this too. -3. And the last one, tack on a -2 at the end.
-5. So it's negative x minus